One of the main uses of the Pythagorean theorem that we're going to have in this course is something that's called the distance formula. And it's going to turn out to be really powerful and give us the opportunity to learn even more about line segments in the coordinate plane. Let me give you an example in GeoGebra to show you what I'm talking about. So let's say I've got this line segment here, and the coordinates here are 2, 1, and over here is 5, 5. And let's say that I wanted to know how long this line segment was. Well, that's a little bit hard to tell right now. It would be easy if I had a line segment that was purely horizontal, like I can tell that the length of that is 3 because I can just count the 3 squares. I could tell that the length of this is 2 because it's just 2 line segments long. But when the line is not horizontal or vertical like this, there's a lot more questions going on. So, how can we tackle the problem of finding out how long this line segment is? I'll give you a hint. It has something to do with the Pythagorean theorem, which we just talked about in the last video. Can you guess what it is? Well, it might be a little hard to see because there's just one line segment there, but let me add in a horizontal line segment and a vertical line segment. Okay, if you want to, pause the video and see if you can figure out from here how long that diagonal line segment is. So now we've created a right triangle because the horizontal line segment and the vertical line segment are obviously perpendicular to each other. So we know that this side has length 3 units, that's easy to count. This side has a length of 4 units, also easy to count. So we can plug that into the Pythagorean theorem to find the length of, what do we call this side again? The side that's opposite the right angle? It's called the hypotenuse. All right, so I won't cut back to a piece of paper with me working this out, but 3 times 3 is equal to 9, 4 squared, 4 times 4 is equal to 16, 9 plus 16 is 25, and the square root of 25 is equal to 5. Or, like I've recommended before, you can just remember that this is a 3, 4, 5 right triangle. So the hypotenuse must be of length 5. In either event, we've figured out that the length of this line segment is 5 units. So that's pretty cool. Just looking at a line segment in the plane, you wouldn't necessarily think that that is something you could use the Pythagorean theorem to solve at first glance, but it turns out that we can. In the next video, I'm going to see how we can solve this on paper if we didn't have a graph that had the points plotted on it that we could count the sides, that we'll figure out how to do that using arithmetic.